All right, everyone. So in this lesson, we're going to be learning about converting grams of one chemical to grams of another. So this is just a continuation of what we did in the previous lesson. So up until now, just to recap and kind of review, we've learned about 3 different conversion factors that we use in dimensional analysis or T-charts. So the first one is molar mass, and remember we use our periodic table to help us calculate our molar mass. And so the molar mass has units of grams per mole. So it's whatever your molar mass calculation is in grams, and it's always equal to 1 mole of your chemical. The second one we learned about was Avogadro's number. Now remember, Avogadro's number is 6.02 times 10 to the 23 particles. And Avogadro's number is also equivalent to 1 mole. Okay? And remember, the word particles can be swapped out for atoms, molecules, or formula units. Okay? And both of these can be flipped where the molar mass or Avogadro's number is in the denominator. The new one we learned about is mole ratio. Now remember, mole ratio comes from the balanced chemical equation. Okay? So if you don't have a balanced chemical equation, then you can't find the mole ratio. And so it requires your coefficient in moles of whatever chemical you have. So we'll just call it chemical A over the coefficient, which is our moles of chemical B. Okay, and so our coefficient comes from our balanced chemical equation. So keeping that in mind, if, for example, you have this equation, it is not balanced, so you have to balance it. So remember, we keep track of how many elements we have on each side. So on the reactant side, okay, so the left side of the equation is the reactants, and the right side of the equation is the products. So on the left side, we have 3 carbons, 8 hydrogens, and 2 oxygens. And on the product side, we have 1 carbon, 2 hydrogens, and 3 oxygens because the oxygens are split. There's 2 in carbon dioxide and 1 in water. And so remember, the hint is to always balance your oxygen last because it can be a little tricky. So let's go ahead and do this. So if we put a 3 here in front of carbon dioxide, what that will allow us to do is have a total of 3 carbons on the product side. And then 3 times 2 gives us 6 oxygens here, plus the 1 from the water, so for a total of 7. So carbons are balanced. If we want to balance hydrogen, we need more on the product side. So if we put a 4 here for 4 molecules or 4 moles of water, 4 times 2 will give us 8 hydrogens, and then we have 3 times 2 is 6, plus 4 oxygens for a total of 10. And so now when we look at our oxygens, the reactant side is the smallest side, and we're going to need a 5 here, so that 5 times 2 will give us 10 total oxygen atoms. And of course, in front of C3H8, there is a invisible 1, or we can write it there. But chemists are kind of lazy. We don't write the 1s. And we're going to be using this balanced chemical equation to answer and use in this example. So our example says how many grams of carbon dioxide gas, so we know that carbon dioxide is CO2, are produced when 100 grams of C3H8 undergoes a combustion reaction with an excess amount of oxygen gas. Now remember, oxygen gas is talking about O2. But when it refers to having an excess amount, that means it has so much that you don't have to worry about. So this is actually meant to distract you. And it's not really an important feature of the problem in terms of being able to determine your answer. So what we want to do is we first want to follow our same steps we've always done. Label what you're given and what you're trying to find. So it says that we are given 100.0 grams of C3H8, and we are trying to find, it says how many grams of carbon dioxide, so grams carbon dioxide. Once you've labeled what you're given and what you're trying to find, you analyze your units to determine what conversion factors you have. So here we see a G. Now remember, grams is in our molar mass. So grams tells us that we will need the molar mass specifically of C3H8 because that is what the grams are next to. So that is going to be step number 1. And then we see here that we have C3H8 in what we're given, but what we're trying to find is carbon dioxide. And so because these are different, we know that step number 2 is going to be using our mole ratio between these two chemicals. Okay, and then now that we're already on this side, we see that we have grams again. And so grams again tells us we're going to need the molar mass, but instead of the molar mass of C3H8, we're going to need the molar mass of carbon dioxide. Okay, so we're going to need 2 different molar masses and a mole ratio. So this is going to be a pretty big problem. So let's go ahead and write this down. So you should be able to calculate the molar mass of C3H8 pretty quickly. So we have carbon and hydrogen, 3 carbons, 8 hydrogens, and we multiply by their mass from the periodic table. So carbon is 12.01 and hydrogen is 1.01. So 3 times 12.01 is going to give us 36.03, and 8 times 1.01 is 8.08. And then our last step is to add them together. And that gives us 44.11 grams per mole. Now, remember, when we write our mole ratio, okay, it can be written, sorry about that. It can be written as 44.01 grams of C3H8 over 1 mole of C3H8, or we can flip it. Those are our options, okay? So that's our molar mass. Our mole ratio, we're going to pull from the balanced chemical equation. So when we look here, we have C3H8 right here and carbon dioxide right here. So we see a coefficient of a 1 and a 3. So that means I can put 1 mole of C3H8 and 3 moles of carbon dioxide at the bottom, or again, we'll have the option to flip it. And then the third thing we need is the molar mass of carbon dioxide. So if we go ahead and calculate the molar mass, we know that we have carbon and oxygen, 1 and 2. We multiply by their mass from the periodic table. And when we do that and then add them all together, we get 44.01 grams per mole. So it's very, very close to C3H8. And just like that, our molar mass can be written as 44.01 grams of carbon dioxide over 1 mole, or we can flip it. And so these are going to be our steps, right? So we can either, so in our first step, we could write our fraction like this or flip it. Our second step will be our mole ratio. And then our last step will be the molar mass of carbon dioxide. And I know that these are going to be the correct steps, but we don't necessarily know what order or which way we'll have to write them. So when we set up our T-chart, our goal is to always let our units guide us through the problem. So the very first thing we do is put our given, so 100 grams of C3H8. Now, because I have grams of C3H8 here, our goal is to get it to cancel out. So that means grams of C3H8 has to appear at the bottom. Now here's the thing. If you look at the molar mass of carbon dioxide, it has grams, but not grams of C3H8. Our mole ratio doesn't have grams at all. So the only one that has it is our mole ratio here. And since it has grams of C3H8 at the top, we're going to have to flip this in order for it to match up. So we'll put our 44.01, oh, sorry, that should be 44.11. I wrote it incorrectly earlier. 44.11 grams of C3H8 on the bottom, and 1 mole of C3H8 in the numerator. And we see that this moles C3H8 does not match what we're looking for, so we're going to have to try to also get rid of that. So we have moles of C3H8 here. That goes on the bottom. Now, when we do this, okay, here's the key step, okay? We've already used our molar mass, so we're not going to use it again. So the only two that are remaining that has moles of C3H8 in it is our molar mass, and we're going to have to flip it because it was at the top. So we're going to have 1 mole of C3H8 at the bottom and 3 moles of carbon dioxide at the top. Now, we're getting closer to our final answer because we do want carbon dioxide, but we want grams of it. So we're going to have to do a third and final step, and we're going to have to cancel out our moles of carbon dioxide. So it has to be at the bottom. And I'm realizing now I forgot to include that there. But if we need to have moles of carbon dioxide at the bottom, that means we are definitely going to write it the way we already had it. So that our 1 mole of CO2 is at the bottom and our 44.01 grams of carbon dioxide is at the top. And so we can see that the units here at the end match what we're trying to find, and so we're ready to put it in our calculator. Now remember, when you put this in your calculator, it's important that your given goes first. So it would be 100.0, and we can just multiply across. So times 1 times 3 times 44.01, and then we just divide by everything that's at the bottom. Divided by 44.11, divided by 1, divided by 1. So again, you're dividing by everything at the bottom, and you're multiplying by what's at the top. And when you do this, you get 299.32 grams of carbon dioxide, which if we're going for 4 significant figures, let's say 299.3 grams of carbon dioxide. So again, this is just kind of how you set it up. It is a lot of work. Don't worry, you won't have too many of these on your test, but it gets rather repetitive if you've done enough practice. So speaking of that practice, go ahead and do it. Okay, the answers are in parentheses for you to check your work. Make sure you balance the chemical equation correctly, though, before you do that. So follow all of the steps. Identify what conversion factors you need after you've labeled what you're given and you're trying to find, and then start plugging them into your T-chart.